Here we are, part 3 of our trilogy on Intro to Solubility. In part 1, we looked at how to use solubility rules to predict and justify if an ionic compound is soluble in water. In part 2, we learned how to write a balanced chemical equation to reflect this solubility prediction. Here in our third and final part, we'll learn how to sketch a Beaker diagram showing which substances are present after the compound is placed in water. There's a trick that drastically simplifies these Beaker diagrams. What you show in the beaker is the same as the product side of the chemical equation from part 2, because that is the final result. And then you also include the water. So we'll start with silver chloride. We determined from the solubility rules that it is insoluble, and the balanced chemical equation showed that AgCl as a solid goes to AgCl as a solid because nothing happens when the compound is placed in water. To sketch the Beaker diagram, we draw a beaker, or whatever this is that I've drawn, some squarish container, include the water line, otherwise it looks empty, and write the H2O. Then we look at the product side of the chemical equation. Because we have a solid, we'll sketch this as a pile of solid at the bottom of the beaker and include the chemical formula AgCl. For calcium nitrate, we determined the compound was soluble, and when we wrote the balanced equation, we had to show that this aqueous compound dissolved into its aqueous ions, and then we balanced the equation. So we sketch our beaker, the water line, and the water. Then we look to the product side and notice we only have aqueous ions, so that's what we write. It's not necessary to include the balancing coefficient in the Beaker diagram, but you do need to include the charges on the ions. In the beaker then, we write Ca2+ and NO3-.